All right, guys, we will get started today. Welcome to today's webinar, a three-part series. This is the first of three with Selenium Academy with CrossBrowser Testing. This is the 101 class, and we're going to do a quick intro on the presenters today. My name is Nick Brown. I'm the CrossBrowser Testing Marketing Manager here at SmartBear, and I'll let John do a quick intro as well.
And I'm John Reese. I'm one of the engineers at CrossBrowser Testing. I'm responsible for our automation platform, including our Selenium grid.
Great, thanks, John. And we'll do a quick overview of SmartBear. We were founded in 2009 in Boston, Massachusetts, and we've grown to over 11 global offices encompassing North America, Europe, Asia, and Australia. We have over 6 million developers, testers, and operations professionals from 20,000 plus companies. Our company has over 500 employees, also provides 5 free tools for the community, including 2 popular open source tools, Swagger and SoapUI. And this right here just shows a quick depiction of all the products that SmartBear has under its umbrella. Today, we'll be focusing on cross-browser testing that you'll see in the testing section within the UI section as well. And then we're just going to do a quick agenda. Today, what are we going to be covering? What is Selenium and why use it? The evolution of Selenium, some Selenium basics, as well as a live demonstration that John will run you through. And then we'll also have time for a live Q&A section. I'll just say before we start this presentation, as we're going through, if questions do come up, please direct them to the QA section in the bottom of your screen, and we will address them at the end of the presentation. And I'm going to hand it over to John.
All right, great. Thanks, Nick. So I'm going to start us off just by talking about what Selenium is. Selenium is a framework for automating web browsers. And using Selenium, you can write code that can do anything in a web browser that a real user or some lines of JavaScript can. You can add items to your cart. You can go through a checkout flow, which makes it great for testing because you can really see, you can make sure that your website works exactly how you want it to in exactly the way a user would actually use it. So why would you want to use Selenium? Well, it runs on just about everything you would want it to. It runs on all major browsers, including iOS and Android browsers. It is open source with a very active community. It's constantly being developed and new features are constantly being added to it. It is very widely used and battle tested by all of the big names, Google, Microsoft, Apple, Facebook, and many, many more. Everyone uses Selenium, it seems. And best of all, there are tons and tons of tutorials and guides and documentation out there on the internet if you ever get stuck. Pretty much any problem you can run into with Selenium, someone else has already run into and has a post or a guide somewhere on how to get past it. So how does Selenium work? I like to think of Selenium as 3 major pieces. You have the client bindings, which are the programming language modules that you install for whatever programming language you want to use that give you the ability to write Selenium in your code. The client bindings talk to Selenium servers, which take in your requests and forward them on to a browser that can run those commands. And those browsers are driven by what are called web drivers. So you can see on the bottom there, kind of the flow for a Selenium command. It starts out in the client bindings. The command will get sent to a Selenium server, and that Selenium server forwards the command to a web driver where the command is executed against the browser. So there are those 3 main pieces. The bindings, the server, and the driver. So why would you use cross-browser testing? It makes it easier to get started. Instead of having to worry about all 3 of those pieces, you only have to worry about getting the language binding installed and pointing your tests to run in the cloud. And we handle, we at cross-browser testing will handle all of the rest for you. We make sure that we have Selenium servers that are up to date and run versions that are compatible with the different web drivers we need to test on all of the different browsers that we have. It takes a lot of complexity out of the equation when you let us manage the backend and you only worry about writing the tests that you actually want to run. CrossBrowser testing also makes it easy to capture and share different test artifacts from your tests, such as screenshots and videos and network recordings. And those test results can be shared with anyone, even if they don't have a CrossBrowser testing account. If you choose to use our Selenium grid, it'll also allow you to run your tests faster with more parallel tests executing at once. You can, for instance, run 1 or 2 dozen tests at once without having to worry about having the hardware to support 1 or 2 dozen instances of Chrome, for example. Being able to run at that higher concurrency allows you to get results faster for your tests and spend less time waiting for them to execute and more time working on your product. And using cross-browser testing also gives you access to thousands of browsers and devices, including real mobile phones that you might not have in your environment, like the Galaxy S8 or the Pixel 3. So where did Selenium come from? How has it evolved? Well, in 2004, Selenium was first started as a just in-house project at ThoughtWorks. And it was very limited in what it could do at first. It didn't work across multiple browsers, and it required being run on the same server that was hosting the website. So as you can imagine, that really limits its usability when you have to be co-located with your server. In 2006, they officially released Selenium 1.0, which added support for a protocol called Selenium RC, which enabled Selenium to run remotely. It no longer had to be co-located on the same server as the website under test. And then in 2008, Selenium 2.0 was released. And with Selenium 2, they shifted from just executing JavaScript in the browser to perform actions and perform validations to sending those commands to web drivers, which would communicate with the browser more directly. Instead of executing JavaScript and being limited by what you can do in, say, the JavaScript console of a web page, web drivers allow you to hook into the browser in a more deep way. So you can do stuff that you can't normally do with just JavaScript, like managing tabs, opening new windows, even dismissing alert pop-ups. Then in 2011, Selenium was finally truly cross-platform, and web drivers were officially maintained for all of the major browsers, Chrome, Firefox, IE, Safari, and Opera, as well as for mobile Safari and mobile Chrome. And then in 2016, Selenium 3.0 came out, which was another protocol shift away from a protocol shift towards a standardized W3C protocol called the WebDriver standard. And they're still working on, with Selenium 4.0 coming out soon, they're going to be continuing to move towards full W3C compatibility. All right, so now we're going to start talking about actually writing and running your Selenium tests. Oops. So if you want to follow along, you can see all of the code at this link on the screen. Sorry if that's hard to see, but it's github.com/crossbrowser testing/selenium-101. I think that's actually selenium-101-webinar. Let me double check that real quick. Yeah, selenium-101-webinar. And I'm going to drop that link in the chat real quick for anyone who wants to follow along. There we go. Okay, and if you do want to follow along, what you're going to need to do is clone that repo. The examples are using Python 2.7, so make sure you have that installed. And once you do, you're going to need to install Selenium, and you can do that with pip install Selenium. That repo includes some web drivers for Chrome, which you will need in order to run the tests locally. We'll also be going over how to run them in the cloud. So don't worry too much if you don't know what that export path command is doing and don't want to run it. We'll get there. All right. So now that we have all that out of the way, I am going to switch to the live demonstration. So I'm going to share my desktop and get my editor on the screen. And we'll start going through these examples. All right, and so what we're doing for these examples, it might look a little strange to some people who have some familiarity with Selenium, and that's because these tests are only using Selenium. They're not using any sort of test framework. They're not using any third-party test runners. I wanted to keep this as simple as possible and show you just how to use Selenium itself without confusing it with different testing agents and runners and platforms and frameworks. Because a lot of people are confused about that. They think that Selenium is a test framework itself, but that's it's not exactly right. It's really just an automation platform for browsers, and you can use it within any sort of testing framework you have. All right, so I have on the screen now a very simple example that will just open a local instance of Chrome using this line here, where we are creating a WebDriver.Chrome instance, and we're giving it a path to that Chrome driver that's also in the repository. The next thing we do is we tell the we send a command to the WebDriver to tell it to navigate to google.com. Once we're there, we tell the driver to find an element with the name Q. And I happen to know that that's the name given to the search bar on the Google homepage. So once this runs, the variable search will be a reference to that search bar. Next, we send some keys to that search bar. We send dogs and sunglasses. And so once this runs, you'll be able to see that text appear in the search bar. And then we tell that same search bar to submit. And that's going to simulate a user pressing enter. This line here isn't a Selenium command. This is just a Python command that will stop the test from executing until I press enter, so that you'll be able to see Chrome running. So I'm going to go ahead and run this. And it's just running with a normal Python interpreter. We see it launched a second version of Chrome, went to Google, types in dogs and sunglasses. And if I go back to my script, at this point, it should just be waiting for me to press enter. And once it quits, the Chrome browser is gone. It cleaned up after itself because we have this driver.quit at the bottom that tells it to close the instance of Chrome. So that's not too bad. Let's take a look at the second example. So in this first example, we've gone to a page, we've found an element, and we've interacted with the page a little bit. In this second example, we're going to be doing some manipulation of the browser window itself. So just to go over this code again, we're going to create an instance of Chrome. We're going to navigate to example.com. and then navigate to this second website that has an example of CSS Grid. And then we're going to perform some navigation actions. We're going to tell the browser to go back and go forward and refresh. And all of these commands are, they can be very useful if when you're testing your site, especially if you have, say, a single page app and you're trying to manipulate the browser's back and forward behavior. This is how you can actually test that and confirm that you're doing it correctly and that it's working across different platforms. So once we do a little forward back refresh dance, we're going to get into this block of code here where we are changing the size of the window. And this sort of command is really helpful if you are testing the responsiveness of your website. You're going to want to be able to change the size of the browser window. So what these commands are going to do is set the browser window to be 325 pixels tall and 900 pixels wide. It's going to set it again and again. And in this for loop, we are going to actually be stepping through sizes from 325 pixels wide to 1300 pixels wide in steps of 50. And this is a nice little a nice way to just test the responsiveness of your site to visually confirm that the layout changes as the width of the browser changes. I can imagine people using a pattern like this, taking screenshots between each different step so they can compare them, or doing whatever it is they need to do. So I'm going to run this as well. So there's our little layout site, and you can see it's stepping through 3 different sizes, and there's our for loop that expanded it out. So commands like this are really helpful for just manipulating the window of the browser that you're using. All right, so in this example, we're going to be going over how the different ways that you can use to find elements on the page in order to interact with them. So just like before, I'm starting up a WebDriver. This time, we're navigating to a little sample Angular website that we have set up that is just a little login form. Let me get it on the screen so you can see it. There you go. So this is the, whoops. This is the little site that we're going to be testing. So it has a username field and a password field and a login button. And it will only allow these credentials through. And so when these credentials are sent and login is clicked, it'll sit and spin for about 3 seconds, maybe 2 seconds, before showing this welcome page. And if you notice, it is more of a single page app style. So the URL didn't change, a navigation action didn't take place. It is all just JavaScript. So if I go back, I can show you what happens if you provide bad credentials. And you'll see the username or password is incorrect error pop up in the top. So in order to test a login form like this, you're going to need to be able to find these 3 elements, the username field, the password field, and the login button, and be able to fill them in. So if I go back to the code over here, I go through a couple different ways to find these elements. So this first example on lines 25, 26, and 27 are using XPath to locate the 2 input fields and the button. And what you might notice about this is a full path through the DOM to the element that we actually want to interact with. Now, if any part of the page structure changes, it's possible that this XPath will either point to something that doesn't exist anymore or point to the wrong element. And that's because using XPaths like this is very fragile. Any change to the page structure could invalidate these XPaths and cause your tests to fail until you go through and update them with the correct values. And for that reason, we tend to avoid using these absolute XPaths as much as we possibly can. The next way is using CSS selectors. And this is a slightly less fragile way to find elements on the page. And if you're familiar with CSS selector queries, it can be very powerful. So in this example, we're looking for a button that has the name of login form and is an element of type input. And because there are two elements like that on the page, the username and the password, we're using a nice little Python syntax shortcut to save the first element that matches this to the username and the second element to the password. And then we do the same thing again for the button element, and we save that as login. Now, the easiest way and the preferred way is by using IDs on any elements that you want to find. And those elements happen to have IDs. So in this case, we get our username just by finding the element with the ID username, and the password by finding the element with the password, and the login by submit. It really is worth it to go through your site and add IDs to any elements that you think that you're going to want to automate, because it really is the most flexible way to do it and the way that survives page changes, that best survives changes to your page structure. So once we have those, that username, the password, and the login all found, we will send our username to the username field and our password to the password field, and then we will click on the login button. So I'm going to go ahead and run that again. Great, and we are now logged in. Whoops, I should press enter. There we go. So now you might notice that the one thing we're missing here is we're not making any sort of validations. We're sending those credentials, but we're not checking to see if we're actually logging in or if we're getting an error. So if I go over to the next example, we start to introduce weights. So just like before, we're going to go to our login form example page. We're going to find our username and password and our login button. We're going to send our credentials and click login. And what you'll notice is, like I said before, that page, it doesn't actually trigger a navigation. So in Selenium, if a button doesn't trigger the browser to load a new page, it won't wait at all before running the next command. So if we were to okay, so there are basically what we want to do here is send our credentials and then wait until either we get an error pop up or until we get the success message. And in Selenium, there are two main different ways that you can wait for a condition like that. The first is an implicit wait. I'm just going to comment these out really quick. So what the implicit wait does, when that command runs, it's going to send a command to the WebDriver that sets a global timeout for that test. and that timeout's called the implicit wait timeout. And that defines how long the WebDriver should wait when trying to find an element before returning an error. The default is 0 seconds. So if I were to comment this line out, so we're no longer setting the implicit wait, and we are immediately searching for our login message after we click login, you'll see the problem here as it runs. So we click, and before the page had time to load, it started looking for the welcome message, and it returned an error. No such element, unable to locate element. So the fix for that is to add a wait. So if we add this implicit wait here, that's going to tell the WebDriver to wait up to 10 seconds for this element to appear before throwing an error. So if we run it now, we'll be able to go through and oops, tester test 1 2 3. Let's see. It wasn't able to find. Oh, it sent the wrong password. Test 1 2 3 4. So I'm going to run this one more time, sending it test 1 2 3. It's going to sit and wait, and boom, it was able to find that text, and it says you are now logged in. So the implicit wait is great to have anytime you have parts of your page that are getting loaded in dynamically, or anytime there's just any sort of waiting involved. It's good to have the implicit wait set so that your tests don't fail if, say, one network call takes too long to run, if it takes more than a second. Setting this to a value of 10 seconds or even something higher like 30 seconds can really help cut down on the false positive failure reports. It keeps your tests from failing. Another way to use weights are with explicit weights. So the difference here is instead of setting a weight that applies globally to the entire test, this line tells the WebDriver to wait for up to 4 seconds for an element to be present. So what's nice about explicit weights is it allows you to set sort of maximum values for what is acceptable for an element to load. And that gives you a whole new way to test your site's performance. You can say, if this element takes longer than 3 seconds to show up, then my test has failed, then that's unacceptable. And it's very explicit to anyone who's looking at these tests, exactly what it's expecting and why it might take some time. So I'm going to run this one more time with this WebDriver wait, this explicit wait, just so you can see that that also works. And there we go. You are now logged in. I tend to prefer explicit weights over implicit weights when I am working with elements that I know will take some time to show up, but shouldn't take more than X seconds to appear. Okay, and now in this example, we're going to be doing the same thing. We're going to be loading that page and sending our credentials. And this time we're going to be checking the contents of that header to make sure that it matches what we expect. So what we're adding into this, this example is one new way to get elements, which is by tag name, because that element we're searching for is an H2 tag. And then we're using a few asserts here to make sure that, for example, the H2 element has a class attribute of ng binding, and that the header is in fact displayed. And then we go and we check that the text is equal to what we expect. And if all of that is true, we'll print this pass line. And if any of those are false, we'll print this fail. I'm going to go ahead and run this for you now. You can see it filled in the credentials. And if we look in our terminal, it passed, successfully logged in. And I'm going to go in and just change what we expect the text to be. And if I run that again, you'll be able to see the failure condition as well. So in this case, the assertion failed, and we see that it did not log in. Something that is really helpful with Selenium, and one of my favorite features of Selenium, is that it can take screenshots of the browser. And that's incredibly helpful when you encounter errors, because you're going to want to be able to see what the browser looked like when it hit that error. That's going to be really helpful for you when you're trying to debug. So I'm going to do the same thing as before. I'm going to set it to the wrong text. Which will force it to fail. And once it fails, it should save the screenshot to the current directory with this file name, onerror.png. So I'm going to run that real quick. You see it's logging in with the wrong credentials. Our test failed, and we should have a screenshot right there. So I'm going to drop back into my shell just to show you what it captured. And there we go. It was able to capture the browser in the state that it was in right when we got that fail. And those screenshot commands, they work if you're using Selenium locally, and they also work when you're running through a cloud provider, like with CrossBrowser Testing. So I'm going to go back into my editor here. I'm going to pull up our last example, which is doing all of the same stuff, the same exact screenshot test, but running with a remote browser. So now we're going to be connecting up to CrossBrowser Testing and running our test on a Windows, on the newest version of Chrome on Windows 10. So what you can see here is I have my username and my auth key, which came from crossbrowsertesting.com. Instead of making a Chrome WebDriver, we're making a remote WebDriver with WebDriver.remote. WebDriver.remote takes two parameters, a minimum of these two parameters. It takes desired capabilities, which tell it which browser to run on and allows you to provide optional settings. And it takes a command executor, which is the URL of the remote Selenium server, the Selenium grid. We're using some Python string formatting here to insert the user and the auth key into the URL. So we're passing our credentials basic authentication style, if you're familiar with that. If you're uncomfortable with passing them in the URL, you can also pass them in your capabilities. And we have documentation on that on our site. So once we get our remote WebDriver instance, we're going to be doing the same stuff. Getting the page, sending some elements, and we're even going to take a screenshot. So I'm going to get set up so I can show you this test running. There we go. Here's an instance of Chrome. I'm going to be logged in over here. So when I run this test now, whoops. Oh, forgot a comma. Need a comma between those two parameters. There we go. And my URL lib3 is out of date, so I'm seeing these SSL warnings, but that's because my Python's out of date. But we can see the test running here. And at this point, yep, it has already run the commands. It happened too fast, I missed it. But we can see all of the commands that it ran right here. If we add record video and set it to true in our capabilities and run it again, we'll also end up with a video of the test run when it's done. So now you can kind of see it run. It logged in, got that error, and it saved a screenshot. The video is being finalized. It should show up in just a sec. There we go. And now this is an easy artifact to share with anyone who needs to see it, to show them exactly where the problem was and exactly what went wrong. And you can share that with anyone just by clicking on this share button. And it'll give you a link that you can send. And I think that was the last example I had, and it was. So that's all of the examples for our 101 class. I'm going to get back to the PowerPoint. And after that demonstration, now we are at the live Q&A.
Yeah, thanks, John. That really did show the true power of cross-browser testing and being able to run those Selenium scripts against our platform and the thousands of browsers and devices that we do offer. I know that was a common question that came up in terms of Selenium Grid and cross-browser testing, and maybe you can address that when we do start the Q&A session. I am going to launch a quick poll if you would like to be followed up with after this webinar with one of our solutions advisor to maybe go through any of your specific use cases when it comes to Selenium, or you're looking for more information on Selenium, or if you want to just overall walkthrough of the entire platform, as we do offer live manual testing as well as screenshot, and then we do have a record in replay feature. So I'm just going to launch that now and give a second for people to respond.
All right, do you want me to go through and answer some of these questions while we wait for the poll numbers to come in?
Yeah, that works.
All right, I see one question from Lakshmi about, the question is, for Angular JS-based applications, do you have any specific built-in functionality? And trying to use Selenium with Angular JS out of the box, you might run into some problems just because of how dynamic Angular JS is. But Google creates and maintains its own testing framework called Protractor, which wraps around Selenium, and it is designed specifically to allow you to write tests for Angular JS. So if you want to use Angular JS with Selenium, look up Protractor. Kin Lee says, so find element by ID is the best function, right? And I think so. I think that the best way to find elements in your Selenium test is by having an ID on that element and just using that ID. Harish had a question. What is the difference between Selenium Grid and cross-browser testing? And the difference is with Selenium Grid, it's a set of software and tools that allow you to create your own distributed system for running your Selenium tests. If you didn't use something like cross-browser testing, you would need to set up your own Selenium Grid using Selenium Server and web drivers and browsers and virtual machines. Jens Nass asks, how can you run the test on multiple browsers now? Because we used Chrome driver in the examples. The easiest way would be to use us as a cloud provider. like we had in example 7, and you would just change your capabilities. So instead of running on Chrome, you would say Firefox, and your test would run on Firefox. If you want to do it locally, you need to set up your own, you need to have more than just Chrome driver. You need to have the correct driver for the browser and version you're trying to run. Let's see. Felipe wants to see a parallel test, and unfortunately that's a little outside the scope of this webinar, but look for it in either the 201 or the 301 class. Finitha Gavini asks, can we test desktop application? And unfortunately, you can't. Selenium is really designed just for web testing and automating web browsers. It is not made for testing desktop applications. If you are looking for a tool that does that, SmartBear makes another tool called Test Complete, which is fantastic for testing native applications rather than web applications, although it can also test web applications. Do you have a repository of training videos? Can you use Test Complete with CrossBrowser? The answer to both of those questions is yes. You can see a lot of training resources at help.crossbrowsertesting.com. That's our help site. And Test Complete does have an integration that allows you to run your Test Complete tests on our virtual machines. For now, it only allows you to run on Windows, but it does let you test to Edge, IE, Chrome, Firefox, across different versions of Windows. Does it support testing Kendo grids? I'm not familiar with Kendo. I'll have to look into that, but thank you for giving me something to look for. Do we need to add any Selenium libraries? I prefer just running Selenium the way it comes without adding too many other libraries on top of it if I can resist, because Selenium alone can be hard to debug at times, and the more layers of libraries and frameworks you add on top of that, the more places there are for things to go wrong and for you to have to look when you're trying to debug. Someone asked, what are the different language supported other than Python? And Selenium has official support for Java, C#, Python, Ruby, and C#, Python, Ruby, Java. I think there's one more, but it's not coming to mind. And there are there's unofficial support in just about every language you can think of. There are ways to write Selenium tests in PHP, in Haskell, in Perl. Pretty much any language you want to use, you're probably going to be able to use it to write Selenium tests.
Hey, John, why don't we pick one more? We're just about at time, so I want to be cognizant of everyone's busy schedule. So let's address maybe one more. And then if we do not get to yours, we'll be sure to follow up with you via email.
All right, let's see. Eddie Ferris asks, I have an application that requires 2 web pages to open at the same time. Can Selenium handle this? And the answer is yes, it can. Selenium is actually really good at manipulating multiple browser windows at once. So as long as those 2 web pages can run on the same machine, you'll have a great time automating that with Selenium.
Great. Thanks, John. And I just wanted to thank everyone that attended today's presentation. It was great to get a kickoff class started for Selenium Academy. Be on the lookout for our 201 class that will happen probably towards the end of August. And we will, obviously send you all emails so you are well aware of it. And there will be a recording sent out sometime this week. So you will have that on hand, as well as the GitHub link. So if you would like to play around with it, we will definitely give you the ability to do that. And thanks again, and everyone have a great day.